Hey guys, how's it going? Welcome to another episode of Ferris Makes Demos. It's episode 50, super pumped about it, blah, blah, blah. By the way, hi to guys in the chat, Mad Moose, Alkama, thanks again for subscribing, really appreciate it. Daru too, Wister too. How's it going, everyone, for the first time tonight? Aaron the German, what's up? Fitty Huggles. Oh, that's great. It did just start, Aaron. You came at exactly the right time. Nothing happened at all before this. Oh, no. The only one, Daru? There's got to be more of those. Oh, you're right, Alkama. Better restart. No, just kidding. Anyway, I want to implement geometry shaders today. It's something I've wanted in the tool in a while, but I haven't done because we kind of needed a reason to use it in a demo. And without saying too much, we totally have a reason for that for revision this year. So that's getting really excited about that. In the meantime, we've released our synth. I think I mentioned that last week as well. And we've been getting a lot of patches and stuff. That's really great. I spent the last couple weeks working on multi-threading for that. That's now merged and ready. So I think we're good. What I'm doing now is I'm just kind of setting everything up again. I updated to latest master, and I'm just using the same public repo, or technically it's a fork that I have, but it matches upstream master right now. So I'm just going to build the solution. Because I haven't ran the demo tool in a little while, so I just want to make sure I can rebuild everything. And this is literally the process that I do, is I open this up in Visual Studio. I need to try it. Kusma of Excess has been working on CMake support instead of pre-make, which helps us to support more Visual Studio versions and also gets us closer to cross-platform. I think Alkama also worked a bit on this. At one point, but we're going to merge that really soon, and at that point, actually before that I'm going to test it, but then I'll probably actually try different Visual Studio versions and see which one generates the smallest code post compression. But in the meantime, I'm still just using Visual Studio 2013 like I've always done. So is everything built? Technically I didn't have to build most of this in here, but I always build everything just in case. So that's built. So now I got to open up another Visual Studio because there's one more, like, Wavesaber has a lot of projects in it. Most of them are VST plugins, just individual projects. And again, those are generated, so it's not like we maintain that many all the time. But when it comes to an intro, we have this core, which contains like the actual DSP code for all the devices, and then the player lib, which has abstractions for creating some kind of player. And then player test is using player lib and core and plays a song, and we use this to actually test music. Standalone player is similar to that. But the idea is that you would be able to take like the player lib, which actually links core by itself, and use that to build whatever abstraction you would need to play songs for your demo or your music player or whatever. And in our case, I have this thing called Wavesaber CLib, which is literally just a tiny C API on top of the player lib stuff. So this has a song that it ends up getting built into it, and then exposes the simple C create, simple C destroy, play, and then get some stuff, tempo and song position, whatever. And this is literally the C API that we expose, or that we use from Rust. So this uses the exact same libraries that you would get in the public release, and then exposes this tiny API that only covers what we need. And because it's only what we need in the intro and not at all complete, I haven't included this in the Wavesaber repo. This is part of our demo tool repo. But it's so trivial. Like, this is literally this, and this is all the code. So I'll build this. And I think there is actually a small difference in here that I want to push, and that's this number of render threads thing now that we have multi-threading. I updated this to test it. And I updated that so that I could get builds of Trash Panda with multi-threaded stuff happening, so I could compare the size of the output executable with those changes, and it was pretty minimal. It's a couple hundred bytes or something that we paid for multi-threading, and that makes the synth 40% faster, 40 to 60. So definitely worth it. But because of that, I have this change, so I need to commit this. Let's branch. I'm on demo bit live show, so let's go to master. I think also I should pull, because I think on my other machine I just pushed all this to master. No, I didn't. I need to look at some commit dates. To see where my latest stuff is. Yeah, the demo bit live show is 2 commits ahead of this. Not much, but we'll do that. Demo bit live show, and I'll pull just to make sure we have the latest. We're good. Take this back, and I think I want to tag that actually. No, I don't do tags for these, I guess. Or do I? No, then I won't tag this. Okay, then I'll just merge. So fast forward. And we don't need most of these branches, actually. I'll keep them in the remote, though. But I'll just push this. Yeah, I can't always tag later. You're absolutely right about that. I'll just keep the branches. That doesn't matter. Though technically I don't need them. Anyway, then we'll commit this change. And that's... yeah. Okay. On a roll. And I need to open a couple more terminals here. And I need to make sure I don't have things lingering on this other one. Okay, we're good. Oh, that's what it was in the demotivation repo. That's where I had those extra changes that weren't merged. But in the Logicoma demos repo, that's where I put everything on master still, I think. Let's do a git pull in case. Should be good. I'm actually going to double check that too, though. Because we have our demotivation repo, which is the tool, and then we have the Logicoma demos repo, which is the demos themselves. Yeah, okay, so this is the latest on master. Must have merged everything already, which is great. So what I'm going to do is go into the Logicoma demos repo, and I'm going to copy Trash Panda. So I can just show you this folder. It doesn't really, I'm not hiding anything in here. And I think in tests, yeah, there's lots of stuff, some unreleased stuff. It's kind of fun. But here, we're going to call this 2019 03 07, and this test is going to be geometry shaders. Just like I had an instancing one where I forked. I'm actually going to show that. That'll be fun. Let's see. I have to open Rocket. Migraine is awesome. I need to publicly release that at some point, because we don't really have a reason not to anymore, as far as I know. Anyway, I was going to open this instancing thing. So it's the sync, and then in the tool, I think I have the latest built. I'm actually going to open up that terminal just in case. I always forget where this is. C program files, x86, Microsoft, Visual Studio. I think it's 12 is the one I want. VC Varzal. I think that's what I want. And then I go to C. I have everything in my MSys. Dev, projects, demotivation, editor, QMake, and nmake. Yeah, this is the, I don't just need the, hold on, Diogo Mitra or whatever. I'm probably saying that wrong, but thanks for following. Duru2, yeah, the Visual Studio command prompt is totally a shortcut for that, and that's awesome, but I need a Qt prompt that also has that set up. And for some reason, that doesn't also do that. I don't know why. Because I need to do QMake and nmake. I could just do 2 terminals there, I guess. But I don't know. I could also do like a my own script that would just run both of those to get the whole environment. That would probably be the easiest thing. Whatever. Anyway. So yeah, this should have built everything. Looks good. And then target editor. Yeah, CD editor, and then target editor. And we'll run Logicoma demos, tests, instancing. No, 2018 something. No, this is 2017 I did this, wasn't it? My whole point for even showing this instancing thing. Oh, shoot. This is why I didn't merge this to master. I'll get to that in a sec. But anyway, so this is Elysian. But you'll notice it looks a little bit different. This is Elysian where I turned it into an instancing test. So this is, I think I draw every cube like 100 times or something with just some random displacement. And other than that, it's exactly the same demo. So it's still like really fast. And I don't think I did that with all the scenes. But I think... yeah, I just did it on some of these. But my point is that I forked the last demo that we had at the time to test this feature, and I'm totally going to do that today with Trash Panda. Tiago Mitra. No, I'm not hacking. I guess I am in a way, but... doing some real-time graphics, I'm hacking the tool that I made to help me do this. I think that's all the scenes where I tested this in. So yeah, I just think this is fun. Anyway, I remembered why I didn't merge this stuff to master, actually. And it's totally because of this add basic mouse pad. And I actually don't want that. So what I'm going to do... oh yeah. Check out demo bit live show. What I'm actually going to do is reorder some stuff. So I'm going to do this. Base this, because I think master only had one other commit other than this. So we're going to do just rewrite history. I'm the only one on this repo, so it doesn't really matter that I do this. Oh, whoops. I meant to do an interactive rebase. Because I want to just reorder these. And 1, 3, B4, CA5. Let's delete that. Okay. That's great through too. So now we have this in this order on this branch, and I want to basically rebase other stuff on this commit. And I think the way I'll do that is I will check out this branch, and I'll do git log. And I think I'm actually just going to rebase onto this and only keep this commit and then rebase that on the other one. I think that's how I'm going to do this. Might be a bit convoluted, but this should be easy enough. Yeah, and so then we rebase this onto this commit. Perfect. That's what I wanted. Great. So that mouse pad thing is it's just a little XY pad that I can use for my laptop's touchscreen when we do live shows. And it's literally just the same thing as when I click and drag in the viewport, but just gives me another way to do that. Because when you do live shows, we have the viewport on a separate window and then the tool like maximized on my local screen. Anyway, run this again. Gonna change the music that I totally wasn't listening to. Yeah, we should be good. Then I can get started on what I actually wanted to do. So in the meantime, I'll open up this other new test file. And go back into here, and I'll rename this test. So all of our, did I remove that too? Yeah, I'm going to do that here too. The work in progress and the party stuff and the shots stuff, because that's for the demo, not this test. Yeah, it looks good. And now I can open this. And we should get Trash Panda running beautifully. I like this demo. So which scene should I do this on? I think it doesn't really matter. I kind of want to do it on this scene. Kick dudes, which is literally what it's called here. So for those of you guys that don't know what I'm about to do, essentially I'm adding geometry shaders. So let me paint some stuff here, as I do in typical me style. So in a programmable GPU setup, the idea is that you have some kind of mesh, a really simple mesh, a couple triangles, and you want to draw this on the screen. So you have this in memory, and you want to get this to the screen. This is a screen. And we're going to draw it a little differently here, just to pretend that some transform happened. I don't know why I'm drawing it like this. This looks like an evil Cyclops robot. But anyway, maybe labels will help. Screen. So the whole idea is that you have these triangles in memory, and you need to do different things to them. So for example, you want to take all the vertices that make this up, and you want to translate them into new positions. And then you also want to fill in all the pixels on the screen. So there's different shader stages. The shaders are just little programs that run sort of in different contexts on different data as it goes through this pipeline. So the first stage we'll have, and I'm leaving out a lot of stages here, by the way, just as a little disclaimer. It's called the vertex shader. A modern pipeline has a lot more than these, but we're just going to talk about 3 of these today. And I'm using these 3 and not some of the newer ones purely out of convenience, because it'll make the code that I want to write a little bit easier than some of the alternatives. But anyway, the vertex shader this is a program here, and this will run per vertex. Let me close Slack as well. Ugh, so much going on today. What happened here? What the hell just happened with my windows? I don't like this at all. What just happened? Guys, I am on fire today. I did not like that one bit. Who is that for? Who wants that? I must have clicked something down here while I was closing Slack. Anyway, this vertex shader is a program that's actually going to run once for every vertex, and it's going to transform it into some new position. And then the fragment shader is something that's going to, so at this point we have like some vertices that are sort of arranged like they would be in our final image. And then the fragment shader is another program, and this is going to run in the context of every single pixel that's on here. So every pixel that's going to be on the screen here, the fragment shader runs. And as input, it takes some values that come across the triangle, and there's a lot of stuff there, but we don't really care about that. This is the part that determines what's going to be, how each vertex is going to be transformed. This is the part that's going to determine what color all the pixels are. Now, there's several other stages in this pipeline, and several other programmable ones, in fact, but one of the earlier ones here that we can do actually sits between these. And this is the one I'm going to add into my demo tool today. And this is called the geometry shader. Let's say geo. And what this does is this allows you to take the transform vertices and do additional transforms on them. Because what happens is between the vertex and the fragment shader is we take our transform vertices and then we make actual polygons out of them. And the way, which polygons there are and the order and stuff, that's all determined by a lot of OpenGL state, essentially, or whatever GPU state you have. But for example, let's say we take triangles in. I think this is called primitive generation, but we take triangles in, or we take a list of vertices that are arranged a certain way, and then the GPU is going to know that the output of those vertices, once they're transformed, it's going to make triangles between them. And again, how it does that depends on a lot of things, but that's all you really need to know. The geometry shader actually allows us to operate on those primitives. So in this case, we're going to output transformed vertices out of the vertex shader, and then primitives are going to be generated. So in this case, it's going to be the 2 triangles between all of our points. The geometry shader is going to see those 2 triangles, and it's going to output whatever it wants, really. The pass-through is just going to produce like the same triangles. But we could do some other stuff, like we could generate a bunch of other triangles on the side of this, for example, which is actually what I'm going to do for the test case, something like this. And then the fragment shader then takes those pixels, and then we would get that as the output. So that's what the geometry shader is for. It's for taking these primitives and just generating more primitives if we want, or no primitives. So we can do like culling of faces with this. We can do all kinds of stuff. But in my case, I want to do just kind of a basic extrude shader. I think as a first step, I won't necessarily do that. I'm just going to do an explode shader. So like if you have a mesh like this, let's say these are your triangles. An explode shader might take these triangles and just move them like this. So you'd get like a triangle out here. That's not a triangle, but that's okay. Another one out here, just based on the vertex or on the normal of the face. So I'm going to do that as my initial test. Again, there's a lot more to this pipeline in a modern setup, but I think geometry shaders appeared like 10 years ago. But we're going to use those just as the most convenient mechanism to do the kind of things I want in our next demo. So to do that, we need a couple things. In the tool here, I have these program nodes. Yeah, Crossbow, no RTX. RTX off in this stream. So if I go through these operators, again, I know it's small, but that's how it is in this tool. I have these program operators, and those will bind a program. And the program is determined by literally a file path to a vertex shader and a fragment shader. Two curves can't explode effect be done with the vertex shader. It can if all of the vertices are actually separated. Then you can do that same effect. But if it's indexed rendering, which means like two vertices that are touching each other between two triangles are the same vertices. So like if those were duplicated, then it would just be moving each one on the normal. But if they're the same vertices, like if it's index rendering and you have like 0, 1, 2, 3, 0, 1, for example, then when you do that explode on the normal, then those two vertices will just go up and the triangles will still be connected. So yeah, it's what Alcama says. The vertex shaders can't generate additional vertices. It's just going to move them around. Geometry shaders can actually generate additional geometry, which is why it's called that. And you can do a lot of stuff with these kind of shaders too. Like you can pass just a bunch of GL points, and then per point you can like generate a sphere or something. I think geometry shaders have some upper limits on how much geometry an individual invocation can actually produce, and I don't think that's very high. And you have the more nowadays you have the more flexible tessellation shader stages. But for tessellation shaders, we need to generate more patch data, and I think that can actually be custom. But the geometry shader stage kind of fits nicely within an existing pipeline that's already doing vertex and fragment operations. So it's not actually as flexible as the most modern setup, but it gives us what we need. And it's a simple thing to add. So Aaron the German says that to a public. No, it's not, unfortunately. At some point, I wouldn't mind making it so, but I would not do support on it or anything. Just because this is just purely my own demo playground. Anyway, this operator here, it takes the vertex shader and the fragment shader. I'm also going to add an optional geometry parameter here. So we need to do that in the tool. And then we need to update the asset manager to actually use those. And I think we need to update some of the underlying engine parts to actually use that as well. Now, I don't think this will be very complicated. As far as I know, the geometry shader stuff is just literally another shader stage. So if I just start going in here, the way I normally like to do this is our demo tool actually has a little test suite in it. And I like to run this first. So Opus is the part of this project. So demotivation is the whole tool. Opus it's split up into several different packages. Opus is just a word that contains the word op in it for operator. This is the whole thing that's concerned with the operator language that's in the tool. And in particular, the test suite that we have tests the compiler. And the compiler takes in that operator graph and it spits out some bytecode. I don't think anything else is actually tested in the tool, like with automated testing, because this is kind of, once this is correct, everything else is actually pretty trivial. And it's pretty obvious when it doesn't work. But this is a nice place to test things and ensure that there aren't bugs on a pretty general level, because everything kind of depends on this core piece of tech. But I think this will just work if we have the test suite running, which is good. Because what I like to do then is, once I see that works, then I can go in and add the features that I want. Yeah, that's so true, Alcama. No, I did do compute, actually. I did that after revision this year, but I didn't do it on the stream. And compute's actually what make the particles in Trash Panda work, because that's a fun way to do it. The tests here are pretty basic. I'm hoping actually that I already have some simple program ops here, because I'm actually going to extend this. And in particular, I'm going to do this because I want an optional string for this. And then I could just add another one. It's like simple geom program. And here we'll do string from. I don't know if this is what you normally call this, but that's what we're doing. Anyway, the program key should now contain that too. The test suite is really basic here, where it's just some input and some output. So this is some description of the operators on the grid, and I expect to get this compiled program out. The compiled program has these opcodes in it here, and then all of this metadata that may be necessary. Not terribly complex, and then we would expect a none here. And if I run this, it actually won't compile. So in proper test-driven development style, we're going to make that happen first, and then we're going to make it pass. And I like to do that at this level because these tests are just so basic like that, where it's just like here's an input and the expected output. And I think it's so nice to just do that piecewise and then fill out the rest of the tech that's going to use that. Just seems like a nice way to do it. And there's all the great errors. Yeah, apparently people use .geom for these, which is great. Anyway, of course, the type was wrong for these items. Yeah, perfect. So now I go in and start actually making this. Oh, I like that too. I wish I had done that. Fish, gush, and fish. Vish. So in ops, this is a big file. There's a lot of big files in the demo tool, but they're all really basic. So for program type name, and then there should be program expr vert and frag. We want to add geom here. And then here in, where's program again? Here. String, option of string, string. That's what we want. And then these are just default values. So actually none is what I want for the default value for a geometry shader operator. Here, a lot of stuff where the compiler just tells me what to do, which is really nice. That's kind of the dream. I'm just gonna split this up now that there's a lot of these. And the nice thing about making the default for this none is that we can add this without breaking any other projects, which is really nice. What does this do? Oh, you know what? These shouldn't be options here. I forgot. All of the expressions are just strings. So we're going to interpret empty string as an option later. So in here, this is wrong. We should do string new. Like that. Yeah, that's what we want. Because we just expose all of this to the editor, or to the UI, just as string editors. So the default one here, again, should just be empty string. That should be good. And then everything should just work. Because the compiler caught this because it's going to return a list of strings. So that's great. And then here, program. So this is wrong here. Ref mute geom. There's definitely some optimization I need to do with this code. Definitely some macro stuff that I could do, but I've been lazy. And at least this is very regular. So I think that's it. And that's it for the ops thing. And then this will propagate now. So if I build this, now the compiler is complaining because these operators are not being represented correctly, or these variants aren't being matched correctly, or however you want to say it. It's actually the parser that should complain about this. And the parser is the thing that takes the operator grid. Like this. And so here we do node data, and I think node data we want to copy this at this point as well. I think. I'm not sure how I want to do that actually, if I want to detect that this is empty here. I'm not really sure. But the node data is the AST node. Yeah, we'll take a string here and then we'll let the compiler deal with that. That's what I decide. We typically return like typed values from the parser. You know what? Actually, I do want to make this an option here. That just feels better to me. Yeah, I like that. And then, so then the parser needs to do this. I'm actually going to split this up a little bit too. I like this case better. I like that. And then that's the parser and the AST. And then we see a lot of these in the compiler, which is the actual different node traversal things. So again, we just let the compiler yell at us till we get it right. Most of these that have to do with the program, or most of these nodes are just really simple nodes that don't actually do anything in the compiler. So you just kind of pass through them. And I explicitly enumerate all of those in these instead of doing underscores just to make the compiler tell me that I'm missing stuff like this. Again, some extra verbosity here in the compiler code, surely, that I could do something more clever with, but I just don't care that much. Because when it's such trivial code changes, I don't mind making them, even if it's more than I need to. So in this case, we'll just actually do this again. We'll just clone it again, because if it's an option, we can still clone that. So that's perfect. Except the program keys type won't match up. But we'll get there. Change this here. Yeah, that's because this still doesn't match up, but I think that's okay. I think this is the last visitor because that's the code gen. And then if we go on top, we can do these program keys, which actually we want the compiled program type here. So it's these program keys. We want an option, a string here. And I think most of that works out, but maybe not because, yeah, we have the program keys here too. I think everything there works. So this would probably make the test pass. No, it didn't. Yeah, export serialization. That's true. that we'll have to get to. And we'll have to change the import stuff as well. Ref geom. Yeah, we'll just do the same stuff here. The only thing I'm thinking of is these chunks, because I think we store lists of indexes into a string table. I think that's how we handle this. In which case, we might want to handle this a little differently. But I do think that's all we do when we serialize this. Serialize programs. How do we serialize these? Serialize program table indices. We push the length. So this length could be 0. And we'll just take advantage of that so we don't actually have to change the encoding at all, which is nice. And what we'll do is we'll separate this out. We'll do this. So we can do let geometry chunks is if let some ref geom is geom. Like this. Otherwise, I think this just ends up being a vector. And then everything else should just work, except like this. It's totally fine, because again, this can just be empty. That doesn't matter at all. And again, shout outs to the Rust compiler, who is making my job very easy here. Telling me all these great things I'm doing wrong. Inferring all my types. It's great. Didn't use this? Yeah, because we want this here. Then that's going to break somewhere else, because this export blob, that needs to change too. And that's actually in the runtime. Is where that type lives. So now we have the programs. No. Programs. Again, indices into the chunk table. Let's do that. And then I think this is almost good, except that we need to make sure that it serializes all of these. And we need this too. We're probably not getting errors here, because now there's probably errors in the lower level stuff. That's kind of one of the things with a change like this. We're going to hit a lot of the code, but at least the compiler is going to tell us everywhere we need to fix this. And that's fun for me. Because now this is wrong because we didn't do this. So we're going to serialize all 3 of these all the time now. Nice hair in the German. Yeah, no need to hide stuff here. assume you mean this one. Because this is pretty much raw data. I think that might cover everything but the runtime. And the tool, of course. Nope, didn't. I'm guessing this is actually other tests. Because I think I have some tests where I just copy and pasted a bunch, so I just get extra coverage on whatever. So this is 1574. No, that's still here. Oh, I need to do some here, first of all. Now we get some other ones. 1657. Yeah, here's this again. Let's do this again, which is going to give us none here. And 1695 had the same thing. Any more? Doesn't look like it. Great. So now all the tests work and they pass, which means that we interpreted that correctly, which is great. And we should see our simple program. These all end up out of order just because the way Rust ends up multi-threading these tests. So I'm not going to spend too much time looking through this, but I do hope to see program was okay, and then we should have had, I think I called it simple geom program okay, so we're good. Obviously, I could have just checked this, but I like to see it in the list just in case. So with that in mind, we're able to basically fix the runtime stuff. Now, first of all, because we already fixed this deserialization in the export blob, things should still work if we just compile and run the export stuff. Of course, this will be misaligned now. So we're going to need to re-export the demo. So we're probably going to have to fix everything up in the demo before we actually make this work. Or in the tool, I mean, before we make this work. But that's not a problem. So let's do that next. Go back to the editor. And then here, I need to do it in this terminal again. So it builds the C++ code as well. This will give us more errors. Yeah, definitely more pro than punk. Just the compiler part's pro, the rest is punk. Yeah, so this is the editor stuff now. So this is in the editor, and way in here, editor context in here. So this is the part that implements the C API that the front end of the tool consumes. So we should have an issue here where a program should be here somewhere. And we just do that. And then this is text for all the operators. And in this case, program isn't specialized, so that's good. This is literally the display text that goes on the operator in the tool. And that's almost it. Next, we get issues in the asset manager. And that's something we need to fix. So I think this is in, yeah, mod. So we want the program map here and program keys. This needs to include the geometry shader string here, as well as the other two. And first, we're just going to make this work, and then we're going to implement the geometry shader part of it. Of course, when I do that, now we have, these are all wrong. Yeah, that's not going to be too bad, actually. Because I think all we really want here is these guys. Because we do chain these watch paths. Okay, but I think this ends up being simple because we just do this. Let shader, we'll do this. Geom watch paths. Shader list is some stuff. And normally, it's just going to be this. We'll start with this. Oops. What? Oh yeah, we didn't do the condition. If let some like that. And this would be shader list. Great. If we just did this, I think that would work as is. But I'm actually thinking I do want to just implement everything. Now that I'm thinking about it. Hey, CPDT, yes, that's exactly what we're doing. That's exactly what we're doing. I'm actually just going to call this key. And I'm just going to copy this crap. This is a clear sign that I just need to make a function that does all this stuff. But fuck it. No, not doing tessellation. Not today, at least. Being very lazy here. And this is going to become geom watch paths. And then this is going to include geom. And this is going to be key. And I think because it's a ref here, we don't need that. And then we're good. So now this isn't defined. That's because we have to go into our own GL bindings here and fix that. Which is called tinygl. And it's going to be one of these. I need to actually look up what this is. glext.h is where these exist. And we'll just open it, Visual Studio. 8dd9. Let's double check that. Yep. That should be all this needs. For this part at least. And they have incompatible types because these arrays have different sizes. We can constrain that and fix that. Here. Haveling, I think that's how you say that. Thanks for the follow. Yeah, all we should need to do here or I think this box slice, I think this GL uint or something. Maybe that fixes it. Or do we need to do that here? I don't remember the syntax for this. I still think this is a vec of path buff. Okay, is that U32 then? It's okay. I've only been using Rust since before 1.0. Destructor? I hardly know her. Oh, this is actually totally going to be a shader. I think that just worked. Okay, that's a good sign. I really need to do this better. But for now, it's okay. Very convenient. This should actually just work in the tool now. Oops. So in this case, if we did, I think this scene is called grow. And it's this one, I'm pretty sure. Yes, it is. I think the liveness analysis in the compiler would have a hard time with that type, Alkama. Oh, I'm such a fucking idiot. Oh, this is one of those days. Oh, that's great. Anyway, so I'm just going to do the grow endpoints here. Now, ideally, we would actually do... Yeah, so we have this geometry shader thing here now. Check this out. If I do this, it breaks, which is kind of a good sign. And then here, it should tell us that it has error loading that asset because it can't find the file. That's actually pretty cool and what we expect, so that's nice. We actually need to update 2 sets of shaders here. The nice thing is that they're all in one place, so I'm just going to go and fork that. I think also I have Logic Coma demos open here already. So if I just do tests, so you guys can see this. Geometry shaders. Assets, grow. We have the G buffer and the light map. I think those are the 2 that we should see here. Light map and the G buffer. Perfect. And I think I'll just do, we'll start with this G buffer one. And we'll just do like a basic pass through geometry shader. I need to look up some stuff here, but this should be really basic. We'll do .geom, and this should be, I think we can actually hook that up already. Okay. Oh, it doesn't like that at all. Why? Yeah, no input primitive type, no output primitive type. So this is actually great. This shows that it's been, or it's being compiled, not successfully but correctly. So layout, I think we do triangles is what all of our things in the tool are using, and we'll call that the input layout. And we'll do I think you need to do like triangle strips, for example. Strip out, void main, and I think if I just save this, they disappear, which is perfect, and that's because we're not outputting any primitives. Great, this is going quite well. So then we would just do GL position is GL in 0 dot GL position. Emit vertex. Same thing here. I guess we have triangles as input here, so I think we want to do this. Probably do that in a loop, but whatever. And then end primitive. Now I would have expected that to work. The tool does not seem to be very happy, which is weird because this actually rarely crashes. But let's just see. It does not like this one bit. That's not fun. Probably because we didn't specify max vertices, but I'm not sure. And I'm not very happy if that ends up making the tool crash, because generally it doesn't, that kind of change. Also, it looks like, now it looks like we're producing primitives correctly. However, they're all black. And I'm guessing it's because we're not passing forward any of the other attributes for the vertex. Because I would guess you still have to do that in the geometry shader. Yeah, so in this case, I'm literally just reading the geometry shader tutorial at learnopengl.com because they're really good references, even if you've done this a lot. No problem in having to read the basics again. No problem. Just moving stuff around here. Yes, here's my vertex shader, and I do it like this. Hey, Zakor. Yeah. I'm probably never gonna link Nihi again, even though I learned a lot from that back in the day. Yeah, so I don't want to change all this to interface blocks right now. Just because I'm going to be lazy here and just try and make it work with the existing shaders. So I think we can just do this and then make all these arrays. And then we should have the same outputs, which actually was the same thing here. So in that case, now we're going to do this as a loop because I'm not going to type all that several times. So in this case, we should set, for example, the position. I think that's all this stuff ends up using is the position, then all these other parameters. And to fit the style here, I'll probably just pass all these through in the same order. So I think it'll be, we might have to rename these. I also kind of wonder if it would be compatible if we did like an interface block in here, but screw it. Let's just do this for now. What was I going to do? Yeah, I was actually going to do this. Yeah. But then we need to do in on all these, which kind of sucks. I don't know if that's the way I want to do this. You know what? Does not matter for this initial test. We'll make it work, and then I'll make it better. It totally is, Drew. Then we should be good. So then we can do position is position in I, for example. I'm about to have some fun. Oh, I love it. And that just worked. So that's exactly what it was. Now everything works. Yes. Awesome. So we're almost there to our basic explode shader now. I'm just going to do that really quick as is. So what I'm going to do here is we have the normal from normal in. So let's do this. We'll take our position, which I think is a vec3, and the normal is also vec3. This is perfect. Then we can just do normal in I times 0.1. And I'm going to pull this down here because when I save that, you'll notice all these triangles start to separate a little. So I can make that more. And I'm guessing, because this is the So the G buffer pass. So, because it looks a little wrong, actually. The lighting's definitely going to be wrong. Oh, I know why. Because we edited the position, which is used in the lighting calc, but we also need to add this to the position in GL position. So we'll just do this. Or actually like 4, 0. There, now they're exploded like that. So let's do this. Vec3 expand is this. I'll call that offset actually. And now we can just play with this. So we can make the offset 0, 0.1. We can make it 10. All kinds of fun stuff. I'm gonna make this 1 just to make it a light effect. And then we would also do this for the light buffer pass. So I'm just gonna copy paste that. I don't have much fancy stuff here for generating shaders. I do have include for generating shaders. But yeah, I usually will do, like for common stuff like this, I would actually put most of this in an included file. But right now, we're just going to do the minimum amount of stuff we need to do to make this work. In this case, we do view position and GL position. So here's what I'm going to do. I'm going to name this to in again, so that this one can take in light map.frag is a vec3. View position in. Oops. And this is probably wrong now. Because yeah, we're gonna do this. We're gonna do this. We can just call this position, can't we? Yeah, we're also wrong. Or are we? Yeah, this is wrong too, because of the projection matrix here. And this actually does it with the view position, so we're totally adding it to the wrong value there. So in both these cases, what we actually should do is we can just do this transform in the geometry shader. Alternatively, we could also calculate the offset vector in clip space. Although I'm not sure if those transforms. Yeah, we'll just do this in the geometry shaders. So we're gonna mess up a lot of stuff here until this works. But I do have the output here, which is gonna tell me stuff until it's correct. So yeah, we're gonna take this in. I think I do that before layout stuff. And then, yeah, so we want the world position out of here. This does calculate the depth, but again, we can do that in the other shader. So we will. Depth, we're still going to produce We're not going to take it in. Now, I think we still need to set geo position, but we're not actually going to use this for anything. Because we're going to replace this anyway. And we have all the other parameters in here. If we wanted to reduce interpolators, I think we could actually stuff that in there, but I like to kind of keep the types in line and we don't really have to care. So that's our world position. And okay, so we actually do want the world matrix here. That's fine. We'll do the view and projection stuff in the other shader. So the normal, we're also gonna have that in world space. Depth is the view position Z, we don't need that. And the view position, we're gonna calculate later. So I think that's all we need there. And then the geometry shader is gonna calculate the position. So what I'm gonna do here actually is vec3, actually vec4 world position is gonna be vec4 position in I plus offset 1.0. Depth is the z. And this becomes four times vpos, I believe. That should be more correct. And maybe this just works. Yeah, this looks like it behaves more correctly because it does. Good. And then we'll go ahead and do the same stuff for the light map stuff. So in the light map one, we're going to just do position here. And take the other matrices in here. So instead of the view position here, this is going to be vertex pos, which comes from this included shader. And geo position again, vec4 0. And then in the geometry shader, we take in the position, we calculate the and these should really reuse some code here, these geometry shaders. But again, we'll be lazy. Maybe I'll split that out in a sec. Anyway, this is going to be vec3 world pos. Do this even. Vec4. This is going to be position plus offset 1. And we do that so then we can calculate the view position, just view times world times this, and then the position is going to be this view pos.xyz. And then the geo position is going to be the projection matrix times view pos. And I'm guessing that then Yeah, and we need the normal in now as well to calculate this offset. So I'm going to do this. And from this one, actually from this shader, we need the normal in. And then that's going to be roll times vertex normal, which we're also going to take in, which I think we already have from that endpoint setup here, which is nice. Yeah, because we always calculate that. And then, where's this? In the geometry shader, we're still failing to compile because of what? Oh yeah. Oh yeah, and world position in this case actually is what we expect. Feel like that's correct. I'm gonna do if we do 0 again here and 0 again here, everything looks just the same as it did before, I think. I'm seeing some weird shadows that I'm not sure make sense. It's probably quite possible that I messed something up here. I kind of don't care that much. To be quite honest. Because it's just a test anyway. I mean, I feel like this already kind of proves that this works. And that's enough for me to test, really. So I'm going to do that. I'm going to put this back here. We should see that there. We should also see, we go back to the scene where we're closer up on those. Same thing. You know, actually, those shadows might even just be that we have holes here now. I'm not really sure. But again, this proves enough that this works, I think. So what I'm going to do now is I'm going to export this for testing that. And this, I think the compiler is going to tell me everything I need to do here again. So from the editor thing, actually I do see some GL errors. I think that's because of the thing didn't compile before, so I'm just going to run this again, make sure that's not the case. Good, no new errors. I'm going to go to Rivet, which is this part that builds the stuff. Cargo build release. And yeah, so now the asset manager implementation in the intro needs to be updated, which is exactly what we expect. So if I go into Rivet, I think it's all just in main. And I think we have the static asset manager. Yep, because programs is this. And the program should include another box for the geometry shader parts. And we need to do this. And let's get the geometry chunks. We do this. So we'll do the same kind of thing here. This probably gives me the same error that we had before, that these match arms don't line up, but we can constrain that by making this a box of shader, not a cat. And I think that's all we actually need to do to get this to work. I think. The other way around? Oh, totally. Thank you. Yes, that is exactly correct. Thanks, Okama. Run this. It does build. I'm going to actually run it like this too. Trash Pamda. I should have done an earlier scene. But the fact that it didn't crash is a really good sign. Actually, this is the same scene. Just all blurry and shit. Music. Yay, it worked. So that's geometry shaders in the tool then. Fabulous. I feel good about this. Might do some code cleanup before I move on, but I'm convinced. Oh, I hate when that happens. I don't want no stinking white space. You get out of there. Thanks, Aaron. I really like that effect. You know, it's funny because I never thought of it as fire until people on Poet said that, and I totally see it now, but I never thought of that when I made it. It's just kind of funny. Yeah, it does look like the Andromeda logo, doesn't it? That's funny. Yeah, I do actually think that I want to clean this code up here. Also, though, right before I do that, I'm going to do one more test on the output executable. I know it works, but I'm going to squish it. Target release rivet exe. I just thought it was metallic particles. I never thought of it as fire. Nice. I don't know if I showed Squishy with this with the latest output text, but I'm really proud of this. And this should still work with a bit of startup time, and that's okay. Great, works. So that's with multi-threading in the synth now and with geometry shaders, which is fabulous. Yeah, so what I was going to do was this little bit of cleanup here. Because I don't love how much not code reuse there is here. And that's just in the... I don't care that much about some of this stuff. But this one was just particularly bad, I think. We can even just do the function here. I don't know if this is a good name, but whatever. And I think, because we want to return the watch path, so it's going to be a vec of string. No, path buff. And box shader. Actually not, it's going to be a shader. And this needs to take a key, which I think is going to be string. We're basically just going to do this, except wherever it says geom here, we're going to make it say, oops. We're going to make it say nothing. That. And this needs to be okay of this. Oh yeah, and then the error type is, I think, just string. That's what I do here. Maybe that's why I did it this way. But we can just take these as input, because I think we just need this, which I think is also like that, string. Oh, and this is actually IO error, which is okay too. Actually, did I just call that error in this file? See, IO error, yeah. We'll do that. And I think I might have done some fancy stuff here. What do I do for load shader here? I do that even. Hey, Dark Second. Aaron, this is just Sublime with Rust Enhanced, I think was the package. I haven't updated it in forever, so I don't even know if that's still what it is. Dead Rules, this is Rust. Oh, you know what? I think if this is path buff, then I think this works out. That's what we need. So then, yeah, we need one more thing here, which is this. And if load shader, that took that as a U32 and called it shader type. So we'll do the same thing here. So the first one we'll do here. Yeah, Team Sublime. I use Visual Studio Code on my work machine. I use Sublime here, and I use Emacs on Mac. I'm a mess. Yeah, it should just be this, actually. Let geometry geom watch paths is load paths and shader. We should give it the key GL geometry shader and program map projector. And that's probably because we need a reference here. Oh yeah, I had the order here wrong. You know what? I'm going to fix that order actually because it makes more sense for me to have the shader first. Whoops. I like that. And I'll do the same thing here. But I'm going to refactor this other stuff in a second. What did I do there? Oh, this is what I did there. And I need music again. How? Oh yeah. That's because I specify this now. Yeah, so that should work. And I'm guessing that we can just go ahead and change these two, which should be key.0, vertex shader, and like this. And I want to do a little better here. In fact, let's actually just do this. I guess I need to insert it into there, don't I? No, we'll do this. Doesn't really matter if we have to build this again. I don't really care. And then pass set. I did do collect, didn't I? Yeah, this is fine. Yeah, I could call this load shader and pass. I like that actually. It's because these match arms here actually have a different type. So I do pass set vector into iter dot do I have flat map? We'll see. X dot into iter. Nope. Of course. I'm so sorry, but I'll be done in a minute. I'm streaming too long today. I'm just gonna do an insert here. That'll help me get this done quicker. Because I can do shader list dot insert one geometry. And then this is not the right type, and that's fine. This will work. And then this one into box slice. And then all the types line up, and then we have proper asset management, which is nice. I hope. We'll build the tool again, and we'll run it again. And it will work, and then we'll commit. And then this is another feature down and gets me one step closer to our revision demo, which I'm really stoked about. Come on. Yeah, that works. Nice. Oops. Done. And then I'm also going to push in the other repo. Man, I really didn't like that moved all my windows earlier. A lot of stuff, but it should all just be for that one project. Okay, then that's everything. Geometry Shaders work. This was a success. Okay, thanks guys for hanging out, and I'll see you next time.